Okay, so chapter 2, we're going to look at transforming radical functions. All right, so this is chapter 2, and this is what your equation will look like in standard form. We still have the parameters. A vertical stretch about the x-axis by a factor of absolute A. If A is a negative, all right, it's still reflected in the x-axis. Your B value. A horizontal stretch about the y-axis by a factor of 1 over absolute B. Okay, I forgot to underline the absolute A up here. If B is a negative, it's also horizontally reflected in the y-axis. H tells you your horizontal translation. So if the H comes out of the brackets and it's a positive, we translate to the right H units. So if H is a positive, translate right. If H is a negative, translate left. If K is a positive, we're going up. If K is a negative, we're going down. All right, so it's all the same as what we were doing in chapter 1. I will get you to take this information down for this chapter. We're going to start discussing domain and range a little more. And the domain will always be x such that x is greater than or equal to your h value. X belongs to the real numbers. And that is when your b value is a positive. So if the b value is a positive number, your domain will be x such that x is greater than or equal to h. If your b value is a negative, if there is reflection in the y-axis, the curve would be pointing to the left, and your domain would be x such that x is less than or equal to h. So that is if b is less than 0. The range, okay? The range is a very similar process, y such that y is greater than or equal to k, your vertical translation, and y will belong to the real numbers. That is if your a value is a positive. Okay, so that would mean there's no vertical reflection in the x-axis. The graph would still be pointing upwards. Y such that y is less than or equal to k. Y belongs to the real numbers. And that is if your a value is a negative. So if there is vertical reflection in the x-axis. Here's what we're going to do. Okay, we're going to sketch these two curves. We're going to make a sketch of y equals 3 times the square root of -1 times x minus 1 in bracket, and y minus 3 equals -1 times the square root of 2x. And then we also want to talk about their domain and range. So I'm going to make a mapping rule, okay, and I'm going to transform my base function. Now just keep in mind that your base function in this particular unit, okay, if we look back to our opening day, we're going to talk about this curve, y equals root x. And the base function, if you remember, 0, 0, 1, 1, 4, 2, 9, 3, 16, 4, and so on. Okay, that comes from that little catalog of essential functions that I gave you on the very first day. So those are the points I'll transform. All right, first and foremost, it doesn't ask us to do this, but let's describe the transformations. Okay, this is already in standard form, so I can describe the parameter A. That is a vertical stretch about the x-axis by a factor of 3. Don't need to say anything about vertical reflection in the x-axis because A is a positive. My b value is a -1. That means there's no horizontal stretch. Don't even need to say this. And I would say there is horizontal reflection. And remember, that is in the y-axis. The line of reflection would be the y-axis. Move on, my h value, it's a -1 in the brackets. When it comes out, it becomes a +1. Right, that would mean translate 1 unit to the right. And my k value, there is no k value, so it's understood to be a 0. That means I would not translate, or there is no vertical translation. Okay. Now let's look at a little mapping rule. So remember, this right here is the curve y equals √x with no transformations. My mapping rule is going to look like this. It's going to be 1 over b. Well, my b value is a -1 times x plus h plus 1. And then it's a times y, so 3y plus k plus 0. That really just means the following. X comma y would be -x plus 1 comma 3y. So what would my new points become after I transform them? Well, let's figure this out. So 0, 0. Let's start with the x values. Multiply them by -1. 0 times -1 is 0, plus 1, I'd get 1. 1 times -1 is -1, plus 1, I'd get 0. 4 times -1 is -4, plus 1 is -3. 9 times -1 is -9, plus 1 is -8. 16 times -1 is -16, plus 1 is -15. And then 25 times -1 would give me -25, plus 1, -24. The y values, 0, 1, 2, 3, 4, 5, I'm just going to triple them. So it'll be 0, 3, 6, 9, 12, 15. And then I would plot these points. Under here, when I delete this, you should see the curve. 1, 0, here it is. So there's the end point. Remember, it's important to remember the blue curve is here. Here's the 0, 0, end point, 1, 1, 4, 2, 9, 3, and so on. Okay, notice there's an end point and an arrow. One end has an arrow on this end and an end point at 0, 0. So think about where that point 0, 0 maps to, because that's going to be the end point. Well, it became 1, 0. So here it is. 1, 0, 0, 3. There it is. -3, 6. There we go. -8, 9. And that's far enough. I'll join those with a smooth curve, and I put the arrow on this end. Now, let's talk about the domain and range of the purple. The domain is always x, such that x is greater than or equal to h, or less than or equal to h, depending on what my b value is. Well, let's just write that over here. What is the b value? B was -1. So remember, when we were talking domain, we said if the b value is less than 0, b value is negative, I got to go with this option, less than or equal to h. And in this particular example, my h value is 1. So it's going to be x is less than or equal to 1. X belongs to the real numbers. The range of the purple is y, such that y is, well, let's see if it's greater than or less than, or equal to, sorry. In this case, my a value is a 3. Okay, right up there, it's a +3. Remember, If the a value is a positive, we're going to go with greater than or equal to. And it's my k value, 0. Y belongs to the real numbers. So this is your k value. This is my h value. The reason this is a less than is because b is a negative. The reason this is a greater than or equal to because my a is a positive. There it is. Yeah, let's do one more. I'll just move the 3 over. So it'll be -1 times the square root of 2x plus 3. See, my a value is a -1. That means no vertical stretch. There is only a vertical reflection in the x-axis. Some people would say there's a vertical stretch about the x-axis by a factor of absolute -1, okay, or 1, but don't need to say that. Your b value is a 2 in this case. And remember, that means horizontal stretch, or it might be more accurate to say compression here, but I'll say stretch, makes no difference. Horizontal stretch about the y-axis by a factor. Remember, it's 1 over the absolute value of b, so that'll be 1 over 2. There is no horizontal reflection in the y-axis because my b value is positive. H, there's nothing in the bracket, so there's nothing in under here with the x. So h is 0, that means there's no horizontal translation. And k is 3. That means there is translation or vertical translation. Translated 3 units up. And again, here is my base function, y equals radical x. If I make a mapping rule, this is what it would look like. It would be 1 over 2, 1 over my b value, times x, plus 0, so I'm not even going to write it, comma, a times y, a is -1, so it would be -1 times y plus 3. So 1/2 x, comma, -y plus 3. And here would be my new points. So half of 0 is 0. Half of 1 is a half, or 0.5. Half of 4 is 2. Half of 9 is 9 over 2, or 4.5. Half of 16 is 8. Half of 25 is 25 over 2. Now, if you want to write 0.5, 4.5, and 12.5, that's fine. Then my y values, these 0, 1, 2, 3, 4, 5, I'm going to multiply them by -1 and add 3. The first one would give me a 3. 1 times -1 is -1 plus 3 is 2. -2 plus 3 is 1. -3 plus 3 would be 0. -4 plus 3 would be -1. -5 plus 3 would be -2. And when I uncover this, we should see those points plotted. Again, here is the original 0, 0, 1, 1, 4, 2, 9, 3. So that's these points right here. Those are the blue points. End point at 0, 0, arrow pointing to the right. The new curve becomes 0, 3. So there's 0, 3. There's a ½ a block up 2. There's 2 blocks to the right up 1. There's 4.5 blocks, don't go up or down. There's 8 blocks, down 1. And 12.5 would be over here and you'd be down 2. But notice, end point here, arrow on this side. Okay? And you can see that the blue curve was reflected in the x-axis, so there was vertical reflection. For domain, we will say x such that, and remember it's x is greater than or equal to, because my b value was a 2. My b is a positive, so I use greater than or equal to. And my h value in this particular case is, if I scroll up, my h value was 0. So if I write 0 here, underline it in blue to indicate that it was the h value, and that means x belongs to the real numbers. So in interval notation, this is what that would look like. It's greater than or equal to 0. So it's just going to go start at 0 and it's going to go right forever. Well, if you think of this as, we can see that endpoint is 0, that arrow is pointing to the right. What's the extreme right of a number line? Well, that would be infinity. So from 0 to infinity. Notice I've got a round bracket in front of the 0 and a square bracket in front of the 0 because it can equal 0, and a round bracket after the infinity. It can't equal infinity. That's an unattainable arbitrary value. Okay, y such that, and that's y is in this case less than or equal to, right? Because my a value is a negative, that's why I chose less than and not less than or equal to and not greater than or equal to. My a was a -1, and it's less than or equal to my k value. My k value was 3, all right? So I'll write less than or equal to 3. Use purple. So that's my k value. And I will say y belongs to the real numbers. And I'll close my bracket. This is set notation. Interval notation. Now this time it's less than or equal to 3. So that means it's going to go from 3 down, right? So what's the extreme? Like if you go down on the y-axis, your y values are getting more negative. So it's going to approach negative infinity. Now a lot of times people write this, 3 to negative infinity. And remember, in interval notation, your smaller number comes first. So I've got to flip those. Negative infinity to positive 3. It cannot equal negative infinity, so I put a round bracket. It can equal positive 3. Okay, so this is the range in set notation. This is the range in interval notation. This is the range, sorry, the domain in set notation. This is the domain in interval notation. I'll let you decide which one you prefer. Okay, so it's really the same thing you were doing in chapter 1, only in this particular chapter you're applying it specifically to the square root of x. You're transforming the radical function y equals root x. These are the questions I'll get you to do for homework, and there's a little assignment there that I'll pass out as well.